labels for old key telephone systems. Category 3 was for Ethernet, Category 4 was for token ring, and Category 5 was for the future. Well, the future has arrived, and now categories 1 through 4 are obsolete. And you always hear people talking about Category 5, and then there's Category 5 Enhanced and Category 6. Now, in theory, Category 5 is the one for 100 megabit per second Ethernet, which is just vanilla stuff. Category 5E is for gigabit Ethernet, and Category 6, in theory, will support 10 gigabit per second Ethernet LANs. Here we're going to take a closer look at H.323, since it's probably the single most important standard when we're talking about voice over IP. And H.323 goes through a number of revisions, and they keep tweaking the title of the standard, but it usually ends up having the words multimedia communications on packet networks that do not necessarily provide a guaranteed quality of service. So let's just examine that title, multimedia communications. So it's not just voice over IP, it's also video over IP, it's data over IP, it's shared web screens over IP, it's whiteboarding over IP. We always talk about voice over IP, but they had grander plans when they were drawing up this standard. And just as an example, if you get a webcam, chances are pretty good that that's H.323 compliant. You're using the same protocols that we're going to talk about for doing voice over IP to do video over IP with a webcam. In packet networks, so what we're talking about here is not circuit switched DS0 type communications, which is what we do in the public telephone network. We're talking about taking the coded speech or video and putting it in packets and transmitting those. Now, as we're going to see when we talk about the coders, some of the coders spit out bits continuously, so you'd be transmitting continuous streams of packets. Other coders are variable rate, and so they only spit out bits and therefore packets when squeaking sounds are coming out of your face. Otherwise, they don't transmit anything. And then the last part, on networks that do not necessarily provide a guaranteed quality of service, well, this could be the internet, but in fact it's actually all of the commercial data networks as well, where we do not have a guaranteed quality of service. And what that means is we don't have a guarantee as to how often we're going to lose packets, and we don't have a guarantee as to how long they're going to take to get to the other end, nor what the variability of that is. And so as we're going to see, we're going to need some protocols to fix these things. H.323 provides a system specification, so it defines what a voice over IP or multimedia over IP system should look like, and it defines a number of entities which form that system. And it defines 4 entities: terminals, gateways, gatekeepers, and multi-point control units. And we're certainly going to look at these as we get deeper into this story. In addition, H.323 specifies the use of quite a number of other protocols. And if we look through this table on the screen, we'll see that H.323 is the system specification, and then another important set of protocols that it references is H.225, and this is the call, control, and setup. And there are 2 main components to that. We've got registration, admission, and status functions, and then we've got the call setup signaling, which follows the Q.931 set of standards. And looking down the list, we see that H.245, the capability negotiation, is going to be an important one that we have to discuss. And then we've got towards the bottom the video codecs or H.26 series of standards, the voice codecs or the G.700 series of standards, and there are a number of other ones. Interestingly, the ITU calls things like call forwarding and voicemail supplementary services, and they tried defining standards for that. But as far as we're concerned, the most important ones here are the H.323 system, the H.225 call setup, and the H.245 capability negotiation, plus the codecs and some other things that have to be added in to make all of this work. So let's review the different entities specified in H.323. And let's start at the end of the story, the terminals. A terminal is an endpoint on a LAN, and this is a key point because right from the beginning we're saying that the phones are plugged onto an Ethernet LAN, and so there are a bunch of implications to that in terms of handling LAN protocols and IP protocols. A terminal has to support real-time two-way communications with another H.323 entity. And at a very minimum, it has to support the G.711 voice codec. We're going to look at codecs shortly. That's the one that's the same as is used in the public telephone network. It produces 64 kilobits per second all the time. The terminal has to support the H.225 registration, admission, and status, and it has to support the Q.931 call setup protocols. In addition, it has to support H.245 capability negotiation. Now that's the minimum requirement on a terminal. Of course, a manufacturer can start adding in all sorts of other fun stuff if they want to, like lots of different types of codecs for coding the voice more efficiently and using fewer bits less often to communicate the same voice information. And we could start adding video screens and all sorts of fun stuff. But the minimum requirement is H.225 setup, H.245 capability negotiation, and the G.711 voice codec. To implement these standards, the terminal is going to have to be an IP telephone, and what that means is that it has to have a speaker and a microphone, and these are the devices that translate between sound pressure waves and electrical analogs on copper wires. It has to have a digital analog conversion capability, and then it has to be able to code the results of that conversion into a standard format like G.711. It has to have a processor in it that can run the call setup and tear down and signaling functions, and it has to be an intelligent IP device. Now, what we mean by intelligent IP device is that it has to act like a computer on the LAN just like your desktop does. It has to have an Ethernet card in it. Well, not an Ethernet card, but if you take a close look at the card that you plug into your desktop PC to plug the LAN cable into, we call that the Ethernet card or the network interface card. Of course, most of the functions are performed on a chip about that big. And if you take a look at that, what you'll see is most of it is a heat sink and wiring. You take the cover off that, you'll see that the chip that does this is about that big. And that's how we implement the LAN access and addressing and all of that sort of fun stuff. So it has to have one of these chips in it. It also has to have a processor and a DHCP client. And DHCP, as we mentioned earlier, is the Dynamic Host Configuration Protocol. This is how a computer on a LAN goes off and asks a DHCP server to assign it an IP address for a certain length of time. And this is called a dynamic IP address. Now, in addition, when we start talking about quality of service, and what we're really talking about there is figuring out how to get quality of reconstructed speech at the far end, What we're going to see is that some of the techniques required for doing quality of service require the terminal to tag the packets that are coming out of it as being voice packets. So that would be an optional function on a terminal if we're going to end up using some sort of network quality of service technique that ends up examining the tags on the packets. It's the terminal that has to put those tags on to start with. The terminal is a thing that spits out IP packets with coded digitized speech in them.